Now, you've already done section 10.1. You guys did that on the day you took your chapter 9 test. The 10.1 I treated like the chapter 10 opener. It was asking you about some exponent stuff. So a lot of the stuff you're already familiar with, but I wanted to have a set of notes that had these vocab words in it as well. So yeah, we're going to review just a little bit before we get into the new stuff. So a power is a product of repeated factors. Is that first blank? Repeated factors. Now, factors are numbers that you multiply together. So if I'm doing 5 times 5 times 5, I could write that as a power because it's a product of repeated factors. Okay. The base is the factor that's being repeated. It's that common factor. And the exponent indicates the number of times the base is repeated as a factor. Why is my text so small? There we go. So in this problem, you can see that they, instead of writing 1/2 times 1/2 times 1/2 times 1/2 times 1/2, decided to write 1/2 to the 5th power. Now, we use parentheses to write powers with fraction and negative bases. So we use parentheses to write powers with fraction and negative bases. That's why they put the parentheses around the 1/2. That shows you the 1/2 entirely is being repeated 5 times, not just the numerator. Because obviously when you put the exponent up there, it could look just like the numerator is being repeated. Okay, so the entire fraction is. Also, if you have a negative fraction, or negative base, I should say, it has to go in parentheses as well, and we'll talk about why in just a second. So let's look at these first 2 examples. How would I write -7 times -7 times -7? Sky? -7 cubed. Parentheses or no parentheses? Parentheses. Just like that. And -1/3 times -1/3 times -1/3 times -1/3 times -1/3. Jimmy? Good job. Okay, so that was a summary of what you guys already did last in section 10.1 that I assigned like 2 weeks ago. Okay, so powers with negative bases. If your power, or sorry, it's your exponent, if your exponent is even, your answer is going to be positive. We already know that when you square a number, it's always positive. Whether your base is positive or negative, doesn't matter because 2 negatives make a positive, 4 negatives make a positive, 6 negatives make a positive, 8 negatives make a positive. Any even number of negatives will make a positive. So if your base is negative and you're raising it to an even power, it will be positive. If your base is negative and you're raising it to an odd power, it is going to remain negative because 2 of those negatives can pair up, but the 3rd or the 5th or the 7th or the 9th one will not. So if you have an odd number of negative signs, there's always one left behind that makes your answer negative. Okay, grab your calculators, please. You'll need a scientific calculator for this. Let's make sure you grab a scientific calculator. Okay, I want you to, in your calculator, type in parentheses -2, close the parentheses, and then raise it to the 4th power. Now, in your scientific calculator, a lot of you have one of these buttons. Some of your buttons look like this. Just however you do it, raise it to the 4th power and tell me what you get. Carson, 16 is correct. Now, I want you to try to do the same thing, but don't put the -2 in parentheses. -2 to the 4th power, Lucy. You get -16. That's why the parentheses are important. Because if the negative number is not in parentheses, only the 2 is the base. So it will do 2 to the 4th power and then make it negative. Whereas the first one does negative 2 to the 4th power, does the entire thing. So the negative sign gets repeated here 4 times because it's part of the base. Here, only the 2 gets repeated 4 times. The negative's just 1. So the answer is negative. That's why the parentheses matter. The way I like to think of it is exponents are nearsighted. Are any of you in here nearsighted? And the glasses help you see farther away, right? The parentheses act as those glasses. If the parentheses aren't there, the exponent is only going to see the number right in front of it, which is the 2. If the parentheses are there, it'll see the entire thing. Okay, so when we write our answer, we have to reflect that. If you see a bunch of negative 2s, make sure you put the negative with the 2 in parentheses. Okay, now do negative 2 to the 5th power. Put it in parentheses. Tell me what you get. Christian? Negative 32. Okay, now do it without parentheses. Just negative 2 to the 5th, no parentheses. What do you get? Someone other than Christian who just did the last one. Emerson? Negative 32. Now here you're going to get the same answer, but for 2 different reasons. Does the exponent see the negative right here? Yeah, so why is it not positive? Xander?
It's an odd exponent.
It's odd. There's 5 of them. So yes, this negative will get repeated 5 times, which of course makes your answer negative. How about an example D? Does the exponent see the negative? No. So it doesn't get repeated. But how many negatives are there? 1. So whether you have 5 negatives or just 1 negative, the answer is negative. So for 2 different reasons, you actually get the same answer. But if you have an even exponent, of course, you're not going to get the same answer because the even number of negatives would make positive 16 in example A, but the 1 negative would make negative 16 in example B. Okay, so the parentheses matter because it tells you what the base is. It tells your calculator, and it tells you. If you're wondering why if we're doing it because our calculators are dumb, our calculators are not dumb. It actually follows order of operations. The negative sign in front of a number, according to order of operations, I could write this like this. So when we do order of operations, obviously we do exponents first, then we multiply. The negative in front of the 2 acts as a -1 multiplier. Now, if I put the negative in parentheses, did someone bring it through? That was like a 3-month-old, sounded like. If I put the negative inside the parentheses, the exponent sees it, so there is no extra step. It's just going to make it positive. Or yeah, some sort of maybe something. Okay, so you had negative bases in your 10.1. That was just to review if you were wondering why some of your answers might have been wrong. And some of you did come to talk to me about that. Just need to go in parentheses. That was really the issue. Now we're getting into new stuff. So that there are several different power properties. The first one we're going to talk about is the product of a power property. And to show you why it works, or show you, first of all, to show you what it is, I'm going to show you why it is. Shut that door for me. Thank you. So the product, 2 to the 2nd times 2 to the 4th. 2 to the 2nd is 2 times 2. 2 to the 4th is 2 times 2 times 2 times 2. Of course, they're being multiplied. How many 2's are being multiplied? Xander? 6. So I could say this is 2 to the 6th power. Okay, next one. I've got -3. Of course, if I'm using parentheses, I don't have to put the multiplication symbol. I could just write them next to each other like that. So there's -3 to the 3rd. And then I'm going to multiply that, just copy and paste, by -3 to the 3rd. How many -3 factors do I have, Christian? 6. And because of negative base, I got to put it in parentheses like that. Okay. X to the 6th is x times x times x times x times x times x times 1 more x. By the way, this is really x to the first power. If you don't see an exponent, just imply that there's a 1 there because there's 1x there. How many x factors are being multiplied together? Maddox? 7. So this is just x to the 7th. And then finally, 10 times 10 times 10 times 10 times 10 times 10 times 10. Martin, how many 10s are being multiplied together? So I write 10 to the 7th. Good. Now, there's obviously a pattern here. There's a rule that you could probably discover, which is when you're multiplying powers that have the same base, and I can't stress that enough, they have to have the same base. If I had a 10 to the 5th and a 9 to the 2nd, this doesn't work. If I've got x to the 6th times z, this doesn't work. So, but if they have the same base and I'm multiplying them, I can add their exponents together. 2 and 4 make 6. 3 and 3 make 6. 6 and 1 make 7. 5 and 2 make 7. So the product of a powers property says you can add, you can add the exponents together when you're multiplying with the same base. Takes us to our next one, which is the quotient of powers property. This one's going to use some canceling. 2 to the 4th is 2 times 2 times 2 times 2. 2 to the 2nd is 2 times 2. This is my favorite one because I like canceling. Those 2's cancel out. I'm left with 2 to the 2nd power, which we know is 4, but we're going to write it as an exponent right now. Y to the 7th. Y times y times y times. Y's are looking really bad. Let's see if I can make this look better. Why am I writing so many of these? Why did I make it 7? 2, 3, 4, 5, 6, 7 over y times y times y. And again, cancel, cancel, cancel. How many y's am I left with? 4. Do I need to go on? What's the pattern here? What am I doing, Deegan? Exactly. I'm going to subtract the exponents. These two 2's are going to cancel out 2 of these. These 3 y's will cancel out 3 of the 7 on top and leave me 4, right? So I'm just subtracting. So 5 to the 6th divided by 5 to the 1st is 5 to the what? 5th. A to the 10th divided by a to the 9th is a to the first power. We can just actually write that as a if it's to the first power. Okay, but yeah, to the first power would be fine. Okay, so you got it. The quotient of a powers property says if you're dividing powers, again, with the same base, you're just going to subtract the exponents. So if you're multiplying powers, add the exponents. If you're dividing them, subtract the exponents. Now, notice when you do this, you're not actually dividing the bases. You're just subtracting the exponents. 2 divided by 2 is 1. You're not going to get 1 to the power of 2. In this problem, 5 divided by 5 is 1. You're not going to get 1 to the power of 5. You leave the 5 there. The only thing you do is subtract the exponents. Our third property is the power of a power property. So x squared to the 4th power. So it's going to repeat 4 times. I like this property because it actually uses another property. This property is going to use the the product of a power property that we just talked about, which says if I'm multiplying powers with the same base, I will add the exponents. So of course, if you don't believe me, 1, 2, 3, 4, 5, 6, 7, 8. There are 8 of them there. You would have got that if you did 2 plus 2 plus 2 plus 2. But if you could just go back and look at the original problem, how would we have gotten x to the 8th from this? Adding the powers, Sky? Multiplying the powers. If you're raising a power to a power, you just multiply the exponents. So we've got adding the exponents if you're multiplying powers, subtracting exponents if you're dividing powers, multiplying exponents if you're raising powers to another power. And that's where we'll leave off for today. So wherever that puts you, I think right now, actually, you could do 10-2 and 10-3 and start 10-4. No, that's not true. 10-2 and 10-3. I think 10-4 is negative exponents. So you could do 10-2 and 10-3. You can go ahead and get started. Remember that homework is due Friday.